Good morning, everyone. Not sure if can you hear me well. To me, it's a pleasure to be here and talk to you about part of my research that certainly has to do with language. And before I started, which one is this one? Okay, okay. Ah, yeah. This- Oh, thank you. Okay, thank you. Now, can you hear? Well, otherwise I can use the microphone.
Sorry,
Okay.
you can just.
Okay. There you go.
Yeah.
Okay, well, I'm thrilled to be here and talking to you about language. And imagine for 1 second what happens if we couldn't talk to each other, if we couldn't share any story, if we couldn't share, communicate our feelings, emotions. Imagine what would happen if we cannot communicate our achievement, technology, history, read books. Well, language happens in other animals. You can see that dolphin can communicate through high pitch sounds. You can see as well that large apes can communicate to signs, but they cannot talk. And although parrots can learn as many as 1,000 words, they don't have the capacity that humans have, which is to create complex ideas through grammar, syntactical, organizing the words. Now, the interesting thing, and you may know, that capacity relies on the brain. And we know for more than 100 years that the brain is the seat of language capacity. However, it's not represented like that. By far, it's much more complex, as more than 100 years ago, phrenology thought it was. Basically, what they thought, that specific bits of the brain was involved in specific capacities, abilities, or faculties. What we know today is actually there are some specialized areas in the brain involved in specific linguistic representations. And the important thing is that the dominant hemisphere, which is in most cases in the left hemisphere, has certain areas that are intensively activated when we listen to language or produce language. And those areas, they are segregated and interact with each other in order to produce language. And those areas are shown here and basically represent part of the temporal lobe, part of the inferior parietal lobe, and also here. Yeah. Okay, yeah. You can see here, need to show this. Oh, here it is. So, as I mentioned before, language is represented. There are some regions in the brain that are specialized in processing language representations. And the most important ones are the ones that are surrounding the lateral fissure or sylvian fissure and involve, to a large extent, the temporal lobe, parietal lobe, and in the pre-central or pre-sylvian region, which is shown here in blue, are the frontal regions, in particular Broca's area. Now, the interesting thing that those areas work together in a harmonic way, but can be selectively affected by the effect of neurodegeneration. And we know some cases of famous people that have been suffering from language difficulties. We know recently the case of Bruce, not Bryce, by the way, and Terry Jones, that had this progressive deterioration in language. Now, when we see somebody with language, we see a constellation of problems. And those problems are very specific, very difficult to identify. And the reason is because language is not an easy task. It varies from one to another, and different components, so linguistic components can be affected. As a result, the manifestation, especially early on, can be very difficult to characterize. So it can be normal in some people that we have some problems with finding difficulties as a normal expression of some language capacity. And I'm going to give you a challenge. Unfortunately, I didn't bring any dictionary, but imagine what is to retrieve a word. If I say the words serendipity, how long does it take to search that word in a dictionary and then come up with the word? However, we can do that almost automatically. It takes no more than 200 milliseconds to take a word for our internal dictionary that should be around a highly educated person about 60,000 words. So imagine the sheer speed how we have to do that and achieve that. And how much knowledge we've got through many years that I grew a number of words, and those words has to be organized, has to be pronounced, and has to be coherent with the idea that we want to convey. So imagine just for a second how complex it is and how little room for mistakes we've got. So when something's going wrong, you have to imagine that many things can go wrong. And one of the things that we do in order to understand what is going wrong is to understand the processes that underpinning language production or our capacity or underpinnings or language understanding. So just I'm going to give you a very simple idea about how we produce language. So if you want to say something like the dog is in the house, the first thing that we have to have is an idea.
I just want to check something. Oh, yeah. The people on Zoom are having difficulties hearing, so I'm just trying to fix this.
By the way, feel free to interrupt me anytime. I want to do this as interactive as possible. I know some topics can be complex, but feel free, please, to ask any question if something's not clear. I'm very happy to explain as I'm talking to you.
Basically, just stand here.
Okay.
Don't
Okay. So I won't move, I promise, to the people that are earlier. Okay. So imagine that I want to express an idea through a sentence. The first thing that I have to do, I have to think clearly about what I want to say and have an idea of the keywords that better represent that. And if I want to say the dog is in the house, I have to have an idea about the house, an idea about the dog, a process that is pre-linguistic and is called conceptual preparation. For that process, it's critical to know the words that I want to say, to have an idea, a visual or conceptual representation of those words, and to be very specific so that I can go to the next step where I retrieve the specific words that better represent those items. In this case, it's house and dog. But even further, we have to come up with a sound of that word that is very specific for each language. In English, it's house and dog, but still it's not complete. We are just mentioning two words and no an idea. And here is where sentence construction or grammar plays an important role. And basically what I do, I combine those words and then add other words that somehow specify the relationship of those words. So in this case, I'm saying the dog is in my house. But we don't say like that unless you are a foreigner like me when you first start talking to English. When fluent speakers, they do it like this. The dog is in my house. And what we do here We include other components. Sometimes we limit some sounds, we do it faster, we stress in the dog and in the house. And also we've got some pace. We don't do it slow like a robot or Stephen Hawking kind of speaking. We do it following a natural way to do it. As you can see, each of those processes can be affected. And as a result of the specific process involved, we can have different problems with word production, or sentence production, or language production. And that is our job, trying to figure out which of those stages are affected. And why we do that? Well, basically, because we know that those processes are supported or subserved by different regions of the brain. And please, you have to excuse me, this is an oversimplification of reality. But if we want to localize those components, we can see that the conceptual preparation relies largely across the whole brain, but a key area where all that information converge is the anterior temporal lobe. Then, if we want to talk about the downstream processes, we see that the lexical retrieval, especially to do with the sound of the words, is mainly in the posterior superior temporal area and inferior parietal lobe, the so-called temporal parietal lobe. And finally, all to do with the implementation of the articulation procedure, and articulation is mainly in the inferior frontal lobe, although other areas of the frontal lobe, including the primary motor area, supplementary motor area, are also involved. As you can see, there are two important things here. The labor of the different components of language production is integrated across distant regions. As a result, we have to connect them in order to produce language. And as a result, we're not talking about a single area. We are talking about a collection of areas that conform a large-scale network. And that means that they are connected not only anatomically through specific white matter bundles, but also through functional, in terms that there are ways I will investigate and see how those areas are functionally connected. However, that oversimplification has some problems. And I will show you why we've got some problems and why we're still doing a lot of research in order to understand that. Despite the problems, there's something very important. And we know that dementia is not a random or diffused condition of the brain, but rather dementia tends to affect very specific regions, at least at the very beginning of the disease. And that is key because it happens that in primary progressive aphasia, some of those regions can be initially selectively affected. And that is the concept that I want to explain now, how primary progressive aphasia is not only an academic enterprise. It's a key to understand one of the most intriguing aspects of dementia, which is the neural vulnerability. Why a common disease like Alzheimer's can affect the language network instead of memory network, as happens in most people. Why some conditions like frontotemporal dementia pathology can affect specific regions and no other in certain people. And that is an important aspect, because if we understand why neural vulnerability happens in those areas and not in other, although can be the same pathology, we can understand what kind of factors can make the variability in common diseases like Alzheimer's disease. And the interesting thing that when those regions are mainly affected, you can have different symptoms. So in case of the broadest area, frontal area, simply what we're going to have more language problems, incapacity to articulate properly, pretty much like I'm talking to you now with some agrammatism, with some language problems. Whereas if we got problems here in the temporal parietal junction, the main problem is going to be with our capacity to retrieve the words. Somehow we know the words, but we cannot come up with the words straight away. We know the concept, we know what we want to say, but it takes a while to come up with words, or if we do, we say the words, there are some mistakes in the way how we articulate the words. And finally, if we've got a deterioration in the in the anterior temporal lobe, what is going to happen? We're going to gradually lose our capacity to understand language. Basically, our language will be fluent and devoid of content because we don't know the meaning of the things. We are losing our internal dictionary and we don't know what words means to us. Paradoxically, we can say those words clearly. So, based on that, and because those regions tend to be differentially affected by different pathology, we see that there are different colors in the problems that can emerge as a result of the language network destruction by neurodegeneration. And when you've got more problems in producing words, in the articulation, in the timing of words, or constructing sentences, we've got the non-fluent agrammatic variant. When we've got problems with our capacity to understand the meaning of the words, we've got the so-called semantic variant. And finally, not least, we've got the logopenic variant, which literally means the loss of words. When we do not retrieve the sound of the words, although we've got a grasp of the concept that we want to say. The interesting thing that these variants and these areas of atrophy are associated with specific pathologies. So in the case of non-fluid, we've got neuronal loss associated with tau inclusions, which is part of the frontotemporal dementia spectrum pathology. The same is true for semantic variant, but in this case, we've got TDP43 inclusions. And finally, and the most interesting one is the logopenic, because those cases don't have any of the pathology commonly seen in frontotemporal dementia. Basically, we've got Alzheimer's pathology. So, I'm going to invite. Any question? Moment? Yes.
Can you just repeat the name of the blue one? It was a temporal.
Oh, yes. That is the region here, is the temporal parietal cortex. Parietal cortex. Basically, although it's shown here in colors, the boundaries is not so neatly as shown here. And that is an important concept because you can see that one common cause of aphasia is a stroke. However, neurodegenerative diseases, the boundaries of the lesions are not well defined. So we've got epicenters of atrophy that we are able to measure using some MRI analysis, for instance, of the cortical thickness. And that adds a little bit of complexity because although you can have some atrophy, still some neurons can be working, which is very different from stroke when all the neurons are dying, but still the surroundings are preserved. Okay, probably you've seen that before. In order to understand those groups and to find the association between clinical symptoms or clinical deficits or linguistic deficits, the pattern of atrophy and the underlying pathology, researchers and clinicians made some diagnostic criteria. And those are not completely perfect, but this is the way how we can communicate, and we can have a common language in order to understand what is happening. And you may see here that we've got the behavioral variant that is out of the scope of this talk, and we've got the language presentation. As I mentioned before, we've got three variants: the semantic, the non-fluid and grammatic, and the logopedics. And for each of those variants, we've got a specific deficits. And interestingly, those specific deficits are associated with a specific or characteristic distribution of atrophy that is showing here. So in the frontotemporal, a behavioral variant of FTD, the atrophy is mainly in the frontal lobes, whereas in the semantic, as I mentioned before, is in the anterior temporal lobe, in the non-fluid, in the so-called Broca's area, which is the inferior frontal gyrus in the left side, the dominant side, and finally, the logopedics, which is basically in the inferior parietal cortex and the superior temporal posterior temporal gyrus. Then the interesting thing is that each of those clinical features and distribution of atrophy can be associated with the specific pathologies. And what we know is that the semantic variant is associated with TDP43 and in less extent tau. But despite of those associations that I will show you with those lines, there's a big problem here, because those associations are not perfect. And as a group works very well, but we want to identify those associations in single cases. We always will find that some cases with semantic, for instance, can have Alzheimer's, or people with non-fluid can have TDP43. And now, what is the relevance of understanding the underlying pathology? Sorry, let's skip this. It's basically this. When we see a patient, or GPs, or clinicians see a patient, what they see is first an impairment in daily functioning. And then when we're trying to figure out what is the main cognitive domain affected, and for that we conduct a clinical assessment. But the ultimate goal is to know what is the pathology, what is the molecular changes that are happening in the brain. Because in that way, we can potentially develop some drugs, some interventions that at least can stop the progression of those biological, pathological processes. But as I mentioned before, and here's the demonstration of our studies, when we're trying to categorize patients in each of those groups, we fail. And we fail for two reasons. One, because some of those features can be present simultaneously in patients from different groups. And second, because some of those features are very difficult to explore. And not surprisingly, when we're trying to analyze using some pathological examination of the brain of those patients, we see that there's a lack of correspondence. So you can see that although in the semantic, most cases has TDP43, still a group has some Alzheimer's. The same is true for non-fluid. Whereas in the logopedics, as we showed before, most cases have Alzheimer's. However, still a proportion can have other pathology. So we learned two things about this. First of all, always Alzheimer's can be a cause of primary progressive aphasia, although it's more common in the logopedics. But second, some cases it's impossible to predict the underlying pathology based on the clinical features only. And as I mentioned before, the idea is that if we understand the clinical symptoms, if we understand the distribution of atrophy, we can predict the underlying pathology. And the reason is because in the future, there are many clinical trials going on that try to tackle the molecule that is affected. And if we understand the biology and we stop the biology, potentially we can treat two important aspects. And the two important aspects are this, prevention and stop progression. Prevention has to do if we understand the mechanism of neural vulnerability. Potentially we can do something to make those neurons strong. And stop progression if we understand how the disease spreads in the language network, for instance, as it happens in PPA. Potentially we can slow down the progression. Those two key mechanisms are critical in order to devise effective or disease-modifying treatment. Now, how we deal with this problem here, we use what is called the ABC of dementia research. And basically, we use three important elements. Our goal is to understand the biology, the underpinnings, the molecular changes that happens in the brain, and see how those changes account for the pattern of atrophy. But we always start with the clinical and cognitive changes, because that is the way how clinicians first encounter the patients, and that is the way that's closest to the clinical expression. That paradigm probably will change in the future, but at the moment, our interest is going through the clinical assessment, because we can measure the different deficits. We can have model about how different brain mechanisms and cognitive mechanisms can fail and yield the language difficulty. And in order to deal and have a thorough understanding of this process, we are keen to understand the basis of some cognitive or linguistic deficits in terms of the neuroanatomical basis of cognition, which allows us to know exactly which region of the brain is responsible for the failure of specific regions. But also we want to know the correlations. If we've got a specific syndromes, we want to know what is the most common pathology associated for that. And then if we understand the association between specific proteins that are accumulating in the brain and cause atrophy, we can understand mechanisms of selective vulnerability and progression. So part of our research, it's been creating and using those tools that are easily applicable by GPs, that can help us to give us a probability about which groups of PPA can be. And in that case, we've got two tools that have been already published. So we've got the SIGPAT, basically it's a naming task where we can separate the major PPA groups. And recently, David conducted this very interesting study where a widespread task as the A's can allocate a probability of classifying PPA cases across groups. And finally, we're working in a scale to assess word finding difficulties, because one of the problems that we find that some of those language problems can happen when the language deterioration has been very advanced. And sometimes at the very beginning, many people, especially higher educated people, may not show such difficulty with naming or with producing, understanding language, because they can compensate very well. However, there are other hints that can help us to distinguish where finding difficulties that happen as we grow older versus the ones that can be due to a complicated disease like Alzheimer's or frontotemporal dementia. At the beginning, this is a preliminary result. We see that some of those features are present in elderly people, but also most of the cases that really have a pathology in the brain can have worse performance in that scale. So we've got some difficulties, as I mentioned, but also we've got some opportunities. Basically, the linguistic profile is very difficult to assess. I'm trying to show you very briefly the complexity of understanding language and how brain organizes language and how inter-individual variability can be very difficult to assess when we talk about language deficits. As opportunity, we see that the study of primary progressive aphasia offers a unique paradigm to understand the relationship between brain and language and how a specific cognitive domain can be affected by different pathology. That can shed some light about the mechanisms of neural vulnerability, in particular to Alzheimer's disease, which is a common disease, but for some reason, some cases present exclusively with language problems. And currently, the classification of primary progressive aphasia includes a diverse group of people showing some language difficulties that is quite heterogeneous. Can be due to different regions affected in the brain, can be due to different pathologies. And even though we're trying to make sense to those three elements, still some cases are not easy to predict. So we need better tools. We need more patience, and we need your help. Without your help, without your generous time, going through the text, going through the scan, would it be possible to produce this talk? Would it be possible for us to understand that unique condition, which is the human language? Please feel free to ask any question. Yeah.
What about people who can't speak but totally understand what's going on? Like, for example, my husband cannot speak, but he'll point to the things that he needs. He can point to carers, what clothes go first, for example. Various things like this. How would you categorize them?
Yes, that's completely right. Oh, yes. So the question is that in certain cases, we can understand everything, however, we are completely mute. And the question is how you can categorize that, or what is the cause of that?
How do you categorize?
Okay, yes. So I will use this diagram here to explain that. So basically, the main problem maybe has to do with the downstream stages at the bottom here. So if you're not able to implement, articulate, and organize your tongue, your larynx, and all your muscles, you will not able, will be able to produce language. You will be completely mute. However, still, you've got the concept, still you can understand the words, still you've got the words in your mind, and in some cases, even you can write down the word. Okay, that's an interesting thing, because that means that's even further up, and that is an important aspect, because we have to distinguish what is called motor speech disorders, where the main problem is the articulation, versus what can be a linguistic problem, where the representation of the words in the abstract and in the material sound is lost. As a result, you understand, but you're not able to produce or join all the sounds of the words in a coherent way. And if you go to this representation here, probably the main problem is in the frontal lobe. Any other question? know,
Just one
Yeah,
more,
yeah.
yep.
this is a very good question. The short answer, in most cases, is yes. However, there are some cases where that ability can be preserved, and in that case, the only problem has to do with the speech, the linguistic feature, which is our ability to handle language or symbolic representation, is still preserved. And as a result, you may be able to read, you may be able to write. Mhm. Well, that is a very interesting question. It can be several areas. However, you have to assess other tasks, because it can be the case that the only problem is with writing, the only problem can be with reading, but your oral language is preserved. Whereas it's different if you got the oral language of our capacity to understand or speech affected, the case is different. So in other words, there's a dissociation, or some cases can have exclusively problem with reading, exclusively problem with writing. But in a context of widespread language problems, you cannot write, you cannot read, because you don't know the words. So it can be secondary to the core language problems, in some cases. So again, we have to see case by case. And no, my question there.